welcome to the channel. If you're new, welcome. If you're not, welcome back. So this video is basically the continuation of my part one video of what are moles. So I'll be using some words from that video. So if you haven't watched that already and you don't know what moles are, please watch that first before you come in, or else you will be a bit confused. So as promised, I did talk about how to do your calculations with mass and molecular mass and your moles. Now I'm going to talk about how moles can be changed into, well, how to do calculations regarding atoms and molecules and moles. Okay, so just a quick recap. Again, your periodic table is so important. You need to know that. At least have your logbook open. Learn off a few normal common ones like carbon, oxygen, and so on. That'd be helpful. Moles are basically your molecular mass, and one of the YouTube comments asked me if it's the same as like atomic mass, if I remember correctly. It is. It's just a different terminology. I'll talk about that sometime later. And we also know that 1 mole is always equal to 6 times 10 to the power 23 molecules. So a mole of any substance on this earth is equal to 6 times 10 to the power 23 particles of that substance, if you get me. And 6 times 10 to the power 23 is also known commonly in our chemistry words as Avogadro's number. Okay, now let's get started. The next thing that I'm going to talk about is atoms, molecules, and compounds. I know to this day I would be confused between these, and unfortunately, you can't afford to be confused between these words. They're similar, they have similar definitions, and it's so easy to get confused between them. And you can't afford to get confused when you're doing the actual exam. So please rewind this part as much time as you want. Take care when you're listening to this, understand it well before I do the questions ahead. Okay, so atom is the most basic unit of anything on this earth. Everything, every element, anything that you see is made up of the most basic unit that is called atom. So usually in most cases your first chapter would be the history of the atom, so revise that first as well. So that is the basic unit. An atom would be anything from the periodic table, sodium, zinc, anything from this thing over here. Okay? Now molecules. Molecules is a bit different. Next up is a molecule. Molecule is when any atom is bonded to another atom or multiple number of atoms. So anything more than 2 atoms. So more than 2 atoms. Chemically bonded. Chemically bonded is your molecule. So the only difference between molecule and a compound is that your molecule usually is the same atom. So if you see here, both of them are blue. It's the same atom. Now, if you go back to compound, this is where people get confused. It is 1 atom, okay, bonded with, let's say, another atom. But as you can see, your bond is between 2 different atoms. You can see that? It's 2 different atoms. So because of that, this is a compound. So technically, every compound is a molecule, because molecule is any atom bonded with another atom. But not all compounds are a molecule, because molecules have to be the same atoms, if you understand that. Now, just as a bonus, I'm going to add in one more, and that is a mixture. A mixture is when any atom, it doesn't matter if it's the same, well, if it's the same, we don't really call it a mixture, it's different. Okay, excuse my atom here. Okay, 2 different atoms right here, and they are mixed, but they are not chemically bonded. So a good example of this is when you add in salt, NaCl, and H2O. If you really think about it, you can mix your salt and water, and then if you let the water evaporate, you'll get salt back. But at the same time, if let's say, oh, what is a good example? Let's say, let's use salt again as an example. So salt is a compound which is made out of Na plus Cl. Those are chemically bonded, and it's not really easy. It's not easily reversible. You can't bring your salt back to NaCl that easily. Maybe it is, but it is quite difficult. But with a mixture, it's easily reversible. You can go both ways. Okay? So I hope you understand this. What's the difference between your atoms, molecules, and compounds, and as a bonus, your mixture. It's good to know mixture as well. Anyway, those are the most important thing that you need to understand. If you haven't understood that, please go back to the part that I explained this. Still not, just comment down below and I will try to explain it again. Let's say you're given a compound. Now we know the difference between compound. Let's say you're given a compound H2SO4. Very familiar. This is sulfuric acid. Okay, sulfuric acid. You're given this and they're asking you how many atoms are there? It's not that hard. You just count it straight forward. So I have two hydrogens, so that is two, one sulfur, so that is one, and four oxygen, so that is four. In total, that is 7 atoms. Very, very straightforward. It's the most basic things that you get confused with. Let's say H2O. There's two hydrogen and there's one oxygen. So that is 3 atoms. This is important to know because the questions later on will ask you this. Let's say, how many atoms are there in sodium? There's only one sodium. I don't see any number later on. So that is one atom. All right, so that's another aspect to know. All right, let's get going with some questions. First question. How many molecules and atoms are in 1.5 moles of water? First thing that I do is I'm gonna underline some keywords. First thing is they're asking me to find molecules. Next thing are atoms. Sometimes people look at the molecules and they find it and move on and forget about the atoms, so don't forget that. I know there is 1.5 moles of water. First and foremost thing that you should know is water is H2O. Basic chemistry, please know those basics before you go even sitting down for an exam. Don't go to an exam hall if you don't know those basics. Now, our trusty friend, the triangle is back. I use a lot of triangles in my videos, so don't get mixed up between these triangles. That'd be very ironic if it is the helper that is causing you to go fail an exam. Okay, I'm gonna give you a quick synopsis of what this is. This stands for number of particles. Okay, number of particles. The reason why I'm saying particles is because it could be atoms or molecules. Because as you can say, different types of substances, we call them atoms or molecules, just as I said before. This stands for moles, that is the universal sign. For moles, that is N, and this is your Avogadro's number. Okay, so what do? We cover the thing that we need to find. So we know what are the moles. What we're supposed to find is your atoms. I'm going to cover the number of particles because that is what I want to find. And that gives me the formula n multiplied by 6 times 10 to the power of 23. N here is 1.5 and multiply that by 6 times 10 to the power of 23 and that will give me a lovely answer of 9 times 10 to the power of 23 molecules of water. Why is water considered a molecule? Because water is not just made up of hydrogen or oxygen, it is made up of hydrogen and oxygen, different types of atoms. Any type of atoms, different types of atoms, chemically bonded together is a molecule. If it was just H2, then it's an atom or diatom, two atoms of hydrogen. Okay, so that is our first question done for molecules. Second part of that is to find the number of atoms. We know H2O has three atoms, just as I showed you before, two hydrogen and one oxygen. Okay, so whenever you need to find atoms, you need to find the number of molecules first, and then you multiply by the number of atoms. So the answer would be 2.7 times 10 to the power of 24 atoms in 1.5 moles of water. It's as simple as that. Just to give a quick visualization of what I just did above, these two glasses have the same amount of water, okay? So let's say that is H2O, another H2O. The blue is the H. Sorry about the quick drawing. I'm trying to draw it quick. Okay, let's say that's the amount of molecules. If I break those up, there's two of them and four of those. So it's just how you look at it. So if I write the answer from before, there's 9 times 10 to the power 23 of these guys, and individual atoms, there's 2.7 times 10 to the power 24. So this would be more, technically, because we're not considering it as groups. They're individualized. So that's the difference between atoms and molecules in the context of this question. Both of the glasses have the same amount of water, 1.5 moles of water. Hope you understood that better now. All right, let's do one more question. How many atoms, so I underlined that, of ferrium or iron, ferrium is the old name, iron is the more common one, is in 0.25 moles of the element of Fe? Okay, when you see atoms, you should be thinking of my triangle here. So what do? You cover the number of particles. Remember, number of particles could be atoms or molecules. In this question, it's atoms. Okay, so you change that according to the question, it doesn't matter. Okay, atoms. So that gives you the formula, and that is moles multiplied by 6 times 10 to the power 23. Moles is 0.25. Multiply that by 6 times 10 to the power 23, and that gives you the answer of 1.5 times 10 to the power 23 atoms of iron. There you go. As simple as that. Let's do one more quickly. This will be the more common one. How many atoms are there in 150 grams of CO2? Now, we always want the thing to be in moles, not grams. So what do? You just change the 150 grams of CO2 into moles. How do you do that? Well, we know 1 mole is equal to the MR of anything. So you need to find the MR of CO2. CO2 MR is equal to C is equal to 12 and O is equal to 16. 2 of that would be 32. Altogether, that is 44 grams. This question is slightly more complex because we're using two types of triangles. If you don't know this triangle, watch my other videos, okay? So we know in 1 mole there's 44 grams in CO2. How many moles are there in 150? Get the formula mass divided by mR, and that is 150 divided by 44, and that is 3.49. We use the other triangle. Remember, our question was to actually find the number of atoms, so that is moles multiplied by 6 times 10 to the power 23. We know the number of moles, that is that, 3.409 multiplied by 6 times 10 to the power 23, and that would give you the answer. That would give you the answer of 2.05 times 10 to the power 24 molecules of CO2. If you want, you can multiply by 3 to get the number of atoms, because that's just an extra thing. That'll give you 6.136 times 10 to the power of 24 atoms of CO2. So I hope you found this video helpful. I know the last part was a bit rushed, But I hope you understand this and comment down below if you found this helpful. God bless, very best of luck for your exams, and I'll see you with the next video soon enough. Take care, bye.